Fala galera, chegamos ao nosso terceiro workshop do Hackathon da Tom. Lembrando que é uma iniciativa da Tether, da Transfero, da Tom e também da Vega, trazendo esse evento magnífico aqui para vocês. Bom, hoje a gente vai passar sobre introdução em programação de Smart Contracts em TACT, que é a linguagem necessária para você submeter o seu projeto, beleza? Então, novamente, altíssimos profissionais aqui da mais alta finesse e qualidade a gente vai trazer aqui para você. Então, pega seu cafezinho, se acomoda na sua cadeira, que a aula já vai começar. E lembrando que o prazo está acabando. Se você ainda não se inscreveu no DoraRex, nem submeteu o seu projeto por algum motivo, você tem que fazer isso para esse projeto ser avaliado, beleza? Lembre que são $10 mil em premiação e a chance de você mostrar para todo mundo o seu trabalho, o seu projeto, beleza? Então, se acomoda na cadeira, pega um café, que a aula já vai começar.
Hello everyone, welcome. Our series of workshops continues, and today's speaker is Anton Trunov, TACT lead. TACT is a programming language for developing smart contracts on Ton, and today our topic is Introduction to Programming Smart Contracts on TACT, Part 1. So today you will be listening about TACT by its main developer. And before we start, I remind you that our workshops taking place in the context of online hackathon that's going on right now. And if you haven't registered your project yet, you still have 11 days to do it. But now we have a workshop where you can ask a question to Anton. He will answer them at the end. And we also have a pool of 100 Ton coins for those who ask questions. So at the end, we will divide it between you. Okay, Anton, thanks for being with us today, and please start our workshop.
Yeah, thanks, Vladimir, for the introduction. Hi, everyone. Hope we will enjoy our workshop. So let me actually start with the presentation. I believe we have just like only 1 hour. Okay, let me share my screen. Okay, I need to provide some permissions to my web browser. Sorry, I need to quit my browser to actually, for it to be able to provide my screen.
Okay, we wait.
Sorry about that.
Okay, I see we already have questions. It's very nice. So we will answer at the end, but you can ask. And also, if you're watching this video in recording, you can drop your question in the comments. It's we count it too. So let's wait, Anton.
Yeah, sorry about that, folks. Yeah, I hope everything is working now. So let me again try and share my screen, and I will share probably the entire screen. Share. Yeah, all right. I hope everyone can see my screen now.
Yeah.
I'm switching to presentations. Yeah. Right. So let me start this presentation for you. So basically, this part I will keep fairly technically light, although I will be speaking about how.
Anton, sorry, I can see screen. I guess yeah. I think it's better if we will do it without full screen.
All right. Okay. Right. So yeah, this part will be fairly technically not involving. So I will be just talking about some basics of TON blockchain programming. Then I'll be briefly covering TACT, how it's organized, the ecosystem, the community, all that kind of stuff. Yes, this would take kind of 20 minutes, 30 minutes tops. And then we will be trying to do some live coding. So we will be live coding a contract. It's like a Kickstarter campaign or crowdfunding, you can call it. So let's take it away, I guess. So, right, TON blockchain was specifically designed for scalability, and that actually shapes how we should be programming distributed applications for the TON blockchain. So for the purpose of this presentation, I will be assuming that you have some programming background, but not necessarily a ton of blockchain expertise. I mean, smart contract programming, you might heard something about this, but not necessarily a pro. So, but if you are a pro, if you have written contracts for some other blockchains, some other platforms, then you might be actually interested in learning these 6 bullet points. So let me actually mention that smart contracts, they resemble, I would say, objects in object-oriented programming, a paradigm that is really familiar to most of you, I hope. And so you deploy a contract. That means you basically do this new operation on an object, right? So contract instances are basically objects. Right, so first of all, contracts pay rent for storage. So the longer you keep your contract data on the blockchain, and the larger the storage size, so the more like integers, maps, strings, whatever you have in your contract, the more you pay. So this is like proportional. So that's one point. Another point is that calls between contracts, as opposed to some other blockchains, are asynchronous and non-atomic. So some other blockchains like Ethereum, they have synchronous contract calls, and if something happens in a chain of calls, then everything in transaction kind of gets reverted, so that you get the original state. On TON, this is not the case. So if some chain call is experiencing some kind of error in the middle, then you have to do some, usually you have to do some other actions to actually kind of revert some of that. Right, so, and contracts cannot directly read other contracts' data. That's also a very important thing. So basically, if you want to read other contracts' data, then you need to ask him explicitly, right? So for instance, you send a message to that contract, like, please provide me that data, and that contract sends you that piece of data back. So this is like back and forth, and some people might call this this actor model, right? So the fourth bullet point is that contracts bit code is actually mutable. So some other blockchain platforms, they don't really let you mutate your contracts code, the deployed code. But people actually get around this restriction by creating so-called proxy patterns. So basically what you do is you deploy your data and your code separately, right? And then this data stuff you keep all the time in the blockchain, and the data part has some kind of pointer towards what code you should be actually using to process this data. And with TON, these are actually updatable, right? So because in practice, no one works with immutable code, because you actually want to do upgrades, you want to fix bugs, but this is actually explicit in the code. So usually you should provide some kind of mechanism for the users to opt out, so they can see what kind of code they will be using. And people usually use the so-called time lock technique to provide this extra level of guarantee. So for instance, the contracts code will be upgraded at some point later, and people actually have the time to review the exact changes to the code, well, in principle at least, and then agree or disagree. And if they disagree, there should be a mechanism to actually, for instance, withdraw funds and like not participate in this kind of activity. By the way, I hope everything is working, because I don't hear anything back. So can someone say something so I understand that I'm not talking to the void? Okay.
Yeah, everything is fine.
All right, perfect. Thank you. Yeah. Right. So yeah, the last point was contracts bitcode is mutable. Then the next point is that you should actually split your data across multiple contracts. So this is basically for the ones who have some experience with other blockchain platforms. So essentially, you need to use your blockchain as a hash map. And we will actually be talking about this a bit later when we will be talking about this concrete example, the case study. And there are no externally owned accounts, so everything is a contract account. So this is as opposed to Ethereum, for instance. And so you basically can, for each public and private key pair, you can deploy as many wallets as you want, basically. So let me actually delve into TACT and provide some kind of high-level overview. So first of all, this is a statically typed smart contract language, and it has explicit support for message-oriented programming. So this stuff that I mentioned just before, that contracts are supposed to be actually sending messages back and forth. And also it has support for reusable code, for reusable components called traits. So basically you can, if you're familiar with something like Open Zeppelin, like abstract contracts in Solidity, this is kind of the same thing. Or you can call these interfaces, for instance. If you're familiar with Rust, this is not exactly Rust traits. It's more like reusable code with state, for instance, so like pieces of contracts. We will be actually looking at those really briefly a little bit later. TACT stands for tone actors initially. It has familiar JavaScript or TypeScript-like syntax with lots of curly braces. And it is an open source project, which it was originally developed by Steve Korshakov, the original author and developer of the language. Currently, it is implemented as a transpiler into FunC. So some people sometimes say that TACT is kind of syntactic sugar on top of FunC. This is actually not true. TACT is a separate language, but technically it is implemented as a compiler into FunC, so into a fairly high-level language. So TACT is implemented in TypeScript, which is, this might seem like a peculiar language to be writing compilers in, but it is not that bad actually. It's good. And what TACT is helping you with, it also automatically generates TypeScript bindings for you to do some local testing using, for instance, Sandbox. So basically you can emulate your blockchain locally, which we hopefully will be doing either tonight or maybe next time. We'll see if we can cover it tonight. So, for instance, this is how fancy looks like. If you are not used to reading fancy code, then this might strike you as something not really user-friendly. And in my opinion, it is not really user-friendly, although fancy currently provides you some, I would say, tools to make your contracts less gas consuming. So contracts in fancy, they might be kind of hard to read, especially if you're not familiar with it, with its programming model. But on the other hand, it provides you with more gas control. So I would say that at this point, I would write your business logic in TACT. And then if you need to optimize things in terms of gas, by the way, gas, if you're not familiar with blockchain programming, then gas is an instrument that helps you solve the issue of consuming too many resources, because you can deploy a contract that actually spins forever. It just loops and loops and loops forever, and it consumes computational resources of the blockchain nodes, but actually does nothing, right? And so to prevent this kind of thing, users have to, well, someone has to pay for computational resources. So this is called gas usually in the blockchain context. So fancy contracts can be really optimized in terms of gas consumption, so they don't consume too many computational resources. But TACT is much more user-friendly, much more readable language. So if you want your complex business logic, I would say you should go for TACT. And if you need to optimize some parts for gas consumption, then switch to fancy locally, basically. This is kind of resembles, you can use Python for scripting stuff, but under the hood, it actually implemented in like C or C++, for instance. And as opposed to fancy, TACT looks a little bit like this. And actually, this contract does more or less the same thing that is actually shown on the previous slide, right? So, but actually a little bit more. And so by a glance, you can understand that this contract, it doesn't need to be initialized. So this is why it's init is empty here. It's like a constructor, an object constructor. It can receive an empty message, which this is a kind of blockchain specific thing. And it can also receive, so receivers are like object methods. So you can basically call your contract without any additional input, and it would just accept the amount of coins, tokens, toncoins you send to it. Or you can provide additional data. In this case, this is in form of messages. Messages are like structures, structs. And so you can see that it receives some kind of input, basically 2 parameters, and then sends something further, right? I'm not going to be commenting this at this point, but this is like really simple conceptual, right? It is an object that basically, like a proxy, just calls another object's method. That's it. Right. So as I was mentioning TACT versus fancy. So TACT tries to actually hide some low-level details. You basically don't need to parse your messages. So for instance, this part here, this is how we parse this message, or actually, no, in this case, this is not parsing, sorry about this. This is about sending. So this is preparing message. This is like we're building a message and then send it to someone. And in TACT here, this is what this send does, basically. Right. Also, we could be checking how to process incoming messages, but it's going to look kind of the same. And we are adhering to this tooling-oriented development. There is a bunch of ready-to-use tools or tools that are work in progress that you can expect a bit later this year. I would say Q3. Right. So obviously, we don't have the time to thoroughly learn TACT during this workshop or the next one, the second part of it. So how do you learn TACT? So first of all, there is official TACT documentation, which is here, docs.tactline.org. And the documentation is divided into several kind of sections or books. There is a book which covers what kind of operators, expressions, statements, whatever. So it kind of covers the elements of the language, how to send messages, how to receive messages, that kind of stuff. There is a work in progress cookbook that tells you how to do stuff. So, for instance, if you want to do something about access control, which we will be looking at a bit later, you can go here and, for instance, here, how to check sender privileges using ownable trades. So you can restrict who can actually do things with your contract. Right, next. So this is TACT documentation. It's still kind of, so TACT is a young language, and the docs are also kind of young. So if you want to contribute, or if you see some kind of mistakes, typos, whatever, then feel free to open issues. I will provide all the links, and we'll be talking about how we support community and community members who actually want to improve stuff around TACT or around TON in general. The next resource is TACT by Example. This was created by Tal Cole, a prominent member of the TON community. So TACT by Example, I will be providing actually all the links. So it is interactive documentation. You can click some buttons there. So this is a screenshot, so I cannot actually do it here, but you can deploy contracts, you can interact with them, you can read some contracts data, you can send them messages and see the responses. So this is a great resource. It is example driven, so highly recommend checking that out. There's also a really cool TACT course, video course. So if you're into videos, then check this out. This is by Vladimir Alefman. It is on YouTube. I think we can provide, we will provide some links, but it can be easily actually found by just searching. Right, so next, what TACT is providing in terms of tooling ecosystem, right? So first of all, there is the official VS Code extension. There are actually a couple of them at least on the VS Code marketplace. You actually want the one by Convig because it's most up to date. It supports the most features of TACT. And since TACT is a young language, we add more features almost each month. So yeah, be sure to get this stuff from Convig. And it looks like this, but we will actually be looking at this a little bit later during the live coding session. Right, so in terms of editors and syntax highlighting, we also have a Vim or NeoVim plugin. We have a JetBrains IDE. There is a TON plugin which supports both TACT and FunC and has even more integration towards TON blockchain programming. And we have this cool project called Tree-Seater Parser that was developed by a community member using the Grants and Bounties program. And actually, this tool can be used either in some kind of newer, maybe like some editors that probably don't support. So there's TACT language server, right? It was recently packaged again by a community member using the Grants and Bounties program. But if you didn't have this, then you could have used the three-seater parser for syntax highlighting, and also at some point eventually this is going to be used by GitHub to do syntax highlighting for TACT projects, because this tool they have called Linguist, we already have a PR, and what we actually need at this point is some community support. So if you create open source TACT repositories that actually contribute to this goal. So once we have a sufficiently large number of repositories and sufficiently large number of files, then GitHub will add support for that. So you will be getting syntax highlighting, access to symbols, all that goodies. In terms of frameworks to actually build projects, test projects, and deploy projects, there is this framework called Blueprint, which we will be using today during the workshop, during the live coding session. So yeah, we will be actually looking at this kind of real life. So probably need to actually delve into that. If you just want to try TACT in your web browser without installing anything locally, you can use the Nugen IDE. This is ide.nugen.org. So you can, pick a template, start the project from the template, and you can build everything. You can deploy stuff. You can let me deploy it. You can check out the data. So for instance, you can check the result and things like this. So this is a great way to actually try TACT without having to install anything on your computer. Right, let's proceed. Another point that I would like to bring up is that we actually are community-driven project. So there is lots of contributions by community in terms of tooling and in terms of actually contributions to the TACT compiler. And we provide for each and every TACT contributor. So if you fix a typo in the TACT docs, or maybe you propose a new page explaining something, or just improve some explanation, or you propose a new feature in the TACT compiler and implement it, or you fix a bug in the TACT compiler. So you would get TACT contributor SBT, soulbound token. There's also grants and bounties program, and bounties for a bounty program for hackers is coming soon. Actually, I would expect in like 2 or 3 months, around that timeline. Right, so this TACT contributor SBT looks like this on Get Gems. Then there is the TON Grants and Bounties program, and usually the Grants and Bounties team supports proposals to improve either TACT itself or tooling around TACT. So for instance, here I just searched recently these grants and bounties for TACT. As you can see, there is lots of closed issues. So actually, each proposal is a separate issue on GitHub. In that GitHub, so not every one of those closed issues is actually done. So sometimes people's proposals can be shut down, but it doesn't happen too often, I would say. And let me tell you about some successful cases, right? So for instance, this three-seater parser was done by a community member called Novus Nota. and this is around 3K USD, and it took several months actually to implement and test it, and it is currently maintained on TACT under TACT organization. Another one, another one is this series of improvements to the TACT compiler. So a community member under the GitHub handle Gusarich is actually doing this. So as you can see, some of those PRs have already been merged. So he's a TACT compiler contributor. And also there are some cool upcoming tools that will be available, I think, in 2-3 months. There is a static analyzer work in progress, which is based on symbolic execution, which is a really cool technique. All rage these days in the static analysis community. There's also another static analyzer, which is based in monotonic framework. So why have two analyzers, right? You might ask. So the second one, the one which is based on monotonic framework, usually works way faster than the first one. So the first one is a good analyzer to have in your CI, for instance, and the simpler one, so to speak, it is really good to have in your editor, and so you get like instant feedback if you have any issues in your contract. So static analyzers would actually detect those issues automatically without your input. Sometimes they can produce like false negatives, but this will be handled. Either you can silence them, or it will be improved over time, right? So these tools are coming, and here is the third bullet point. This can be your project actually that I can be talking about, and we can discuss, and you can get funded to do that. And we have, as you might actually know, hackathons and contest program, and you are participating actually in one. There are online and offline hackathons, the long-term incentive program from the Open League. There are ton contests, and they believe that there will be a TACT ton contest soon enough. And yeah, this one is probably, you all know about this, that it's actually not too late to join, right? So this hackathon is going from April to June, and you can get registered until May. And there is 2 million prize pool, as you already know, and then top projects might actually get some funding. So how to stay up to date with recent TACT development? You can subscribe to Tone Dev News Telegram channel, for instance, and we will be probably sharing this presentation or the useful links. For me, this is basically, if you scan this QR code, this is going to be a gist on GitHub with all these collection of links, right? So there is a link to the repository of TACT, and for instance, this is it, right? So this is the TACT compiler main repository. We are trying to develop everything publicly. So for instance, you can see here lots of issues. They're all, most of them are tagged, and so people actually can understand what's going on with this project. We try to release TACT around once a month, maybe once every couple months. That depends on the amount of work that gets into the next release. Sometimes, you know, like you want to fix some stuff, you want to add a couple more features, and then suddenly someone from the community comes and wants to merge their stuff in, and I'm actually happy to do that. So that's why sometimes it can get postponed, because there are some unexpected features, and basically the TACT team gets like second priority here, and the community contributors actually get first priority when they come up with some cool things to contribute. So if you are willing to work on something like this, then we provide kind of like help and mentoring. We can provide some support using grants and bounties. So you're welcome to join. And I guess we should probably switch to, yeah, that was the last slide. We should switch to some live coding session. I think, so Vladimir, can you hear us? Is all good?
Yes, everything is good.
Okay, thank you. Right, yeah, so let's switch into some live coding session. I have something prepared, so if I get stuck at some point, then I can probably take a peek at some preparation materials, but otherwise, just let's try to come up with some smart contract. So let's say we want to develop the app that allows you to create and host some crowdfunding campaigns like Kickstarter. So basically, you have a bunch of backers, the people who actually are willing to support your project financially. And we have an owner, so who actually deploys this contract. And of course, this should have some kind of web interface or maybe a Telegram mini app, but we're not going to be, we actually don't have the time to develop a like full-fledged mini app with a blockchain backend, right? So we will be just covering how to create the smart contract and how to test it locally. And maybe if we are successful, we will be actually trying to deploy it on testnet, that kind of stuff. So basically, yeah, we have the owner of the contract, we have the so-called backers, and we have a couple of parameters, right? So of the campaign. So campaign parameters. First of all, we have the duration of the campaign. Actually, I will be.
Sorry, do you share your screen, your code?
Oh yeah. I was sharing. Let me actually. Let me stop sharing and share another thing. Share screen. Yeah, thank you for catching this. Yeah, can you see my editor now?
Yeah, now.
Okay,
Good.
perfect. Yeah, thank you. I totally forgot that I was sharing my browser. So yeah, we have these campaign params. I will be actually adding some more stuff as we go along. So first of all, we need the campaign goal. So the goal would be the amount of money we expect to actually get from the backers, right? And then we will be having a deadline, right? So for instance, a campaign might last for about a month with a goal of getting, I don't know, let's say 1,000 tons or like 1 million tons, something. So there will be backers, and there will be, well, this is not parameters. This will be kind of roles, right? So roles like anyone, there will be anyone, let's say, or maybe let's put it over here. There will be backers, there will be the owner, and anyone else, right? Except for the owner and backer. All right, and let's just start writing this contract. So this contract, I will be calling it crowdfunding. Funding, okay. So this contract needs to have a trait. So first of all, this is deployable contract. To actually do that, I need to import std lib deploy. I hope I didn't mess it up. And moreover, the standard lib actually provides the ownable trait, because this contract needs to have an owner, someone with like an admin role, right? And to use that, I need to import the ownable trait. So if you go to the standard library of TACT, you will see how these so-called traits look like. So they basically, for instance, the deployable trait has this receiver, which actually lets you get this deploy message, which contains the query ID, and then it just responds with a new message repeating this query ID. And the ownable trait, it is implemented like this. So it will have the owner storage field, which is the address of the owner, and it will have this will have a getter, right? So this getter is something that lets the outer world to read your contract's parameters, basically your contract state. In this case, we just return the stuff that is stored in the owner field, and we will have the require owner. The require owner function, which we can call, and this will provide access control. So only the owner can call something that actually checks this require owner prerequisite. And if it's not the owner, then an exception will be raised, basically. So this is how you can restrict who can do some admin functions. All right, so we can inherit from two traits. And in this case, since the deployable trait does not have any storage fields, we don't have to do anything here, but the ownable trait, it is supposed to have the owner, which is an address, right? So we have the owner, and we should have some kind of, so the goal, so campaign goal, let me call it the goal here. It's going to be an integer, int, and here we need to specify actually how many bits of storage this integer is going to be taking, right? So for instance, here we are going to be serializing this into the contract storage, let's say as a unsigned integer with 64 bits. And we also need a deadline, which will be the amount of seconds, basically the Linux epoch time. And we will be also using 64 bits for this. Let's call it like this. Deadline, right? Right, so next we need to initialize, when the contract is deployed, we need to initialize this data, right? So we use this init contract constructor. So the one who deploys the contract will be the owner, and the deployer of the contract, or the owner, needs to provide two parameters. It needs to provide the goal, which is an integer, and the deadline, which is an integer. Again, this init does not return anything, so it's like a special function constructor, right? And to access the contract storage fields, we need to use the keyword self. So self.owner. This is going to be the sender, right? So the one who deploys, each and every receiver or initializer in this case will have this sender field, so you can actually know who deploys this contract or who sends a message into the contract. And the rest of the fields are going to be initialized using the parameters. So in this case, this goal refers to the parameter in the init here. Sorry. Oops. Right. So self.deadline will be initialized to this parameter. And now we need to define the receivers. So it's something that gets triggered only when some user sends a message to the contract, so tries to interact with the contract. And TACT supports, there's this receive keyword. So TACT supports, for instance, string receivers. So if you use your wallet and you just send a comment or memo into this contract when it gets deployed, it will be processed, right? So for instance, we want to donate. We want to donate some amount of coins, right? And first of all, we need to check some preconditions, right? When we can donate. I'm not sure if there are any questions at this point, but hopefully I will either resolve them right here when I'm just will be explaining something a little bit later, or after the workshop, we can discuss things here. So first of all, what we are going to be coding today will be just a really simple version of this contract. And one of its quirks would be it's not going to be scalable. So the version we're going to implement right now, it is easier to understand, it is easy to implement, but it's not going to be scaling to millions of users. It's probably going to be just working for, let's say, 100 users, 100 backers. So when we, in the process of this campaign, of this crowdfunding campaign, so first of all, to receive a donation, we need to make sure that this campaign is still ongoing, that we are not trying to fund a campaign that actually failed already. So first of all, we need to require that the deadline, so self.deadline, is not passed, right, for this campaign. So to actually access time in Unix epoch, so the amount of seconds since January 1st, 1970, if I'm not mistaken. So we need to make sure that now is before the deadline. And this built-in, it actually requires two parameters. So the first one is some condition to check. And if this condition does not hold, then we need to throw an error. And here, the string will be actually explaining what's going on here. So for instance, here, campaign is over, right? So we will be saying something like is over. So we are not accepting these donations. What else? So an owner can actually be also a backer. So there's no reason to forbid that. And let's say we want to each and every person to actually donate just once, and don't donate more than once, right? And so also there should be a refund mechanism, right? So let me put some question marks here. So receive, let's say have a receiver with get refund. So if the campaign is unsuccessful, then the user, the backer, should have a mechanism to actually receive back the ton coins they donated to the contract, right? So that means here we need to somehow remember the amount of money, the amount of tokens the user donated, right? And so here we will be using the non-scalable solution. We'll be using a map. It's like a hash map, right, or associative dictionary. So this is going to be a map of addresses. So from addresses as keys into sorry, typo. And maps are initialized empty, so we don't need to actually initialize it in the init constructor. And so initially, when the contract gets deployed, the backers map won't have any backer at all because there has been none yet. And when we donate, when a backer donates, then we need to, first of all, we need to check if they already donated. So the backers map, we will be calling the get method. So in this case, we have the sender is actually the one who donates, right? So the sender built in, it returns the address of the one who is calling the contract, right? So we'll be saying something like, let, we can just probably say require, right? So we can say, and the get method actually returns an optional type, right? Because there might be no sender. So if it's empty, initially it will basically return null, right? The null value, which indicates the absence of values. And so here, to actually proceed, we will be requiring that it was null before. So this, let me comment here. So the sender did not donate previously. And we will be sending this error message that backer already donated, if it's not null, right? So when we proceed here, both of these preconditions are met. So here we know that it's not after deadline; it's within the deadline, and we know that this key is missing from the map, basically. So we know this stuff, and we need to. And by the way, the amount of tokens the backer sent will be automatically accepted in this case. And we need to just remember this, right? So backers.set. And we need to say something like, and for the purpose of this talk, for the simplicity, I'm not going to be doing any like guess optimizations. So you actually might want to create a separate variable and assign like read the sender here in there, but here I won't be doing this. And so sender, and then we need to actually read the amount of ton coins, and to actually do that we need the context. So let me say this context is going to be context, and I can say context.sender here, for instance. And this is let me switch to the text docs. So if you go there and look up the context, you will see that this built-in returns this context structure. And together with sender, it also has value, which is the amount of non-atom coins in the message. So here, context sender is going to be set to context value. So we remember the amount of ton coins the sender sent to this contract. Right, and this is it, right, in this case. So how do I get a refund? So first of all, we need to require that it is after the deadline, right? So here we're saying that now is greater then self.deadline. Or let's also allow equals, right? And if it's not, then refunds, we will say something like refunds are not possible for ongoing campaigns. All right. Also, to get a refund, we need to actually make sure that the user, anyone in the world can actually send this message, get refund. And if it's just anyone, like anyone else in this role, then basically we do not issue any refunds, right? They did not donate, so why should they get a refund? So here we can say something like let donation of type optional int is gonna be backers.get sender. So the sender of this message, we check if they have this entry in the backers map. And here we will say something like require donation not equal null. Because if they did not donate, donation would be null, right? So in here, non-backers cannot get refunds. And at this point, we know that donation is not null, so we need to basically issue a refund. So for instance, we can do it using the send primitive. So there's the send operation, which takes a structure called send parameters structure, and we need to basically send it to the sender, right? The one who is asking for the refund. And we need to, and if, for instance, if I don't remember how to operate with send parameters, so we need to say value, so how much tokens we are sending. And this is going to be the donation, but we know that the contract actually is supposed to pay rent, right? So we cannot actually refund the whole sum, because if the campaign is going over time, then we need to actually store this info. So let's say we say something like minus fee, and we will be, but not probably fee, but self.fee. So this fee is going to be a constant, or maybe it's a good idea to say something like fee screaming case. And let's say it's going to be 0.1 ton. I'm going to be hard coding all of that stuff, but in a production grade system, you would actually need to do something about this. All right, so we are returning the donation minus the fee that is supposed to be actually spent on computation, because when they donate, so let's say if I donate 100 ton coins, the contract does not actually does not get the contract balance, does not get the full 100 ton coins. It will be almost 100 ton coins minus the amount of ton coins you have to pay for the gas. For instance, the user interface can adjust this amount of, so if you want the backer to actually donate exactly 100 ton coins, then this can be handled. But for the sake of simplicity, let's just go with this hard-coded fee approach. And we also need to specify the mode of this message, right? And then you can see that there is a bunch of modes. And so, for instance, if someone wants to get a refund, then they have to say, okay, I'm sending this amount of ton coins, let's say 0.1 or like 1 ton coin. And so part of that would be spent on this computation before. And so we need to kind of return back the amount of ton coins not only we got earlier when the user called donate, but we actually need to return the stuff we just got for processing this message. And these are actually, this is an integer, so we need to use bit masks. I put here bitwise OR operation, or the junction, because I want to say something like send ignore errors, which is usually what people do here. So let's not probably delve into this stuff right now, because I fear that we might not finish on time. We probably will have to spend like 5 minutes more on 10 minutes more on this. If it's after the deadline, and there's also one more thing that we need to cover here that I did not mention before. That after the deadline, the user can, like a backer, can ask for refund. But the thing is, if we, you can only get your refund if it's an unsuccessful campaign. And so here we need to make sure that the campaign is actually not successful, right? So for instance, here we need to say that my balance, so my balance means the balance of this contract, is actually less than the goal we set. So after the deadline, if the balance is not sufficient for the owner to actually withdraw money, then only then we are allowing to refund the user. So this is get refund, and we also need to allow the contract owner to claim funds, right? So if the campaign is successful. So let's say we call this claim funds. So when we see this message claim funds, we know that someone is trying to get all the funds, right? So we need to actually, first of all, we need to say something like, okay, let me briefly check. So first of all, this should be require owner. So only the owner is supposed to do this. So we can reuse this function, or we could just, for instance, copy paste something and change, for instance, change this into require, or we can, let's say for the sake of trying to understand how trades are working. So this require owner actually comes from the standard library from the ownable.tact file. So here we require only the owner can do it, and also we need to say something like, first of all, it should be after the deadline, because before the deadline the campaign is still ongoing, right? And here we can say claiming funds is not possible for ongoing campaign. And we also need to check that my balance is greater or equal to self.goal. Because the owner is supposed to be able to claim the funds only in this case, right? So when the campaign is successful, which means it is after deadline, it is the campaign goal is met, right? So we have sufficient amount of money. And here we just send parameters. Just send the message. So we can just say sender, because we know that the sender is owner, or we can say self.owner, it's the same thing basically, right? The value here is going to be interesting. So the value is going to be 0. Why? Because there is a special mode for this. And if you go here, you will see that there is a send remaining balance mode. So basically, you send all of it, all of your money in the contract, because the contract accumulates all the money over time, and then after this successful campaign, you can actually, for instance, do it this way. You can send the remaining balance of the contract, and then say something like send destroy of 0. So when your contract has served its purpose, then you can withdraw all the money and destroy it. That's it. Like, you don't need to pay rent, for instance. And I think this is pretty much it. We didn't have enough time to actually test this, and let's do it next time. And next time we can do actually some kind of refactoring to actually remove this backers map here, because it's not scalable. There are some limits that the blockchain imposes on us, and for instance, it just allows you to keep like tens of kilobytes of data in one contract. And so instead of just using this map locally inside our contract, we will be switching to using the entire Ton blockchain as like a distributed map, so to speak. And if you want to try it out, try to do some TACT programming on your own, then I can suggest one refactoring here. So for instance, let's say the owner does not use a multi-signature wallet, and they lose their private key. So that basically means these funds, in case of successful campaign, are stuck forever. Like, no one will be actually able to withdraw funds if the owner of a successful campaign loses their private key. So that means, how to solve this issue, we can add one more deadline here. And so the owner would actually have like a window, like a time interval in which they can withdraw the funds. But if they miss the second deadline, then despite the campaign is successful, the backers would be able to actually withdraw their funds, and this is how we can unfreeze the funds for everybody. We might actually cover this refactoring next time, and then we will be switching to using, we will remove this map and we'll be using the blockchain as our map. Right, so I hope you got an idea how to create, how this Ton blockchain programming can work using this really simple, I would say simplistic example. Don't use it in production. And I think we can start seeing if there are any questions.
Yeah, awesome. Thank you, Anton. It's a very nice workshop, and there are many good questions. So we can start to answer. The first one, I guess you can answer next workshop, but I'll read now. Please let me know if ERC20 contract is far different from Jeton contract. What are the differences? How you think? Will you answer?
Yeah, this is really cool question. So basically, when you talk about ERC20 contract, it is implemented in Solidity as like a huge hash map, right? And so, this is the approach I kind of show to you now. So I would expect that it is really familiar either to Solidity programmers or to just enterprise programmers, like to anyone else with programming experience. And in Ton, the model of programming is really different. So this is actually what we will be covering. And JSONs are really different in terms of implementation, in terms of how you work with the blockchain from ERC20 contract.
Okay, next question is, I see, okay, I see question. Today morning, we calculated the cost for transactions of Jeton minting and NFT minting cost. They're quite expensive. 3 cents, and it kills all the virality. I can answer.
Sure,
because
sure.
maybe you should use standard like C NFTs that I know. Its standard helps to mint huge number of NFTs in one transaction, and it's really cheap. So I believe that you should look at this, and I'll send link in our main group in Telegram in topic technical questions. So yeah, I believe you should look there. Okay, and next question. Yeah.
Can I actually? Yeah. I was looking at my code on your screen, I guess. So we actually forgot to add one thing here. So basically, when we issue a refund, we also need to store that we did that, right? So backers.set, and we need to say that the sender has been refunded already.
Yeah, right. Because
otherwise, you can claim your refund. Yeah, but we will be testing this kind of stuff next time. I hope we will have the time. So yeah, we can probably comment out this change and then see if we can actually catch this with our test.
Next question about hackathon rules. For the sake of hackathon, is it quite challenging to create something the users to pay such big cost? At what degree we need to use Web 2 and Web 3? For example, Notcoin is particularly Web 2. And yeah, I can answer that it's true. And it depends, how to say, by your project. If it's Web 2, it should be clear that it's the first stage. And in the second stage, you will implement Web 3. So yes, it's not necessary to build something like Web 3 on Hackathon, but we must be sure that your project, to understand that in the future, your project will implement Web 3 features. So yeah, like Notcoin, we obviously see that Notcoin right now deploy their own Jeton. Okay, next question. This from account with name Test. Test, please send me your Telegram account. Is there any limit for contract size, megabyte or kilobyte?
Yeah, there are some limits, and it's definitely far less than a megabyte. So it's like tens of kilobytes, as far as I remember.
So yeah, quick answer. How is it possible to audit the contract if it is modifiable? It's a good question.
It is, yeah.
I can say that you should. Answer is continuous auditing. So I think that each significant code change or update requires a new round of audit to ensure that the security and reliability of the contract is good.
And also, you're not supposed to actually modify it at will, right? You're supposed to at least give your users some time. So this is called time locks. It should not be modified at any moment, because in this case, yeah, it doesn't make any sense to audit anything if it can be changed instantly. Like you deployed it, you accumulate money, and then you change the code, and then you can do anything you want.
Yeah, agree. By my opinion, TACT is similar to Swift and TypeScript. Much like these languages replaced Objective-C and JavaScript, TACT transpiles to FunC. What's your opinion on which languages is most similar to TACT? What's your opinion, Anton? Which language is most similar to TACT?
It's hard to say at this point. It is similar syntactically to TypeScript, for instance, but semantically, we have a type system that is pretty simple, I would say. So it's far simpler than the type system of TypeScript, for instance. So it's actually hard to say. It's more like like Java, this kind of stuff in terms of type system. But the mode you operate in is like really different from most languages, because it might not be evident here because of this really simple example, but it actually can be quite challenging to think about like correct inter-contract communication.
Yeah, because of tone architecture.
Yeah, exactly, yes.
Yeah, okay, good. Next question from Vadim. What is the best practice to generate random numbers in TACT?
Yeah, here is basically you use the standard library here, and it is basically fancy. Let me just switch to the random stuff, right? So this is advanced proceed with caution, as you can see. So there's a bunch of stuff here, and in the randomness part, you can see how to like generate a random number, for instance, here. So it's mostly a stub, right, for working with randomness. And if you go to the standard library, you will see that this random int and this random is just some kind of wrappers around fancy stuff. And actually in fancy, it is well kind of a wrapper around TVM instructions. So there's like there are some things in the tone documentation. So if you go to docs.ton.org, then you will see how to there was some kind of thing about randomness, random number generation. Yeah, here we go. So if you study this part, then you probably would see your answer like simply use randomize LT.
Yeah. Okay.
Yeah, but randomness is tricky in the blockchain world. That's for sure.
Yeah, it's true. Exactly. Okay. Next question is about hackathon. Is using TACT commitment or convenience to participate in Open League? Its question is answer is quick. It's not necessary. You can use what you want. You can use both TACT, fancy, and how I said before, you can build a Web2 project in your first stage. So yeah, they are not necessary. Okay. Next question. How combine storing data in databases and in Ton blockchain? Some best practices or advices? Anton, and yeah, I can try to start.
I'm a compiler guy. I know nothing about this.
Okay, so I'll try to answer. In my opinion, you don't have to store data in blockchain. You should store data in databases. But if you want to, but best practice is to store, for example, if you have huge data, or doesn't matter, if you have data, you can do hash from this data and store hash to blockchain. And this is, but it depends of your business logic. So if you want to be sure that data is correct, you should store hash of this data in blockchain and build your business logic. Depends on this. I don't know if I answer on this question, but yeah. Best practice to store data to blockchain is not to do it. Yeah. What's the main advantages of using TACT over other programming languages for smart contracts, such as Solidity?
Yeah, basically Solidity is not available for the Ton blockchain platform. You have like 3 options. You can use Fifth, basically like fourth like assembly language for TVM. You can basically you program in TVM instructions. You can use FunC, which is an intermediate level language. Or you can use TACT, which is again an improvement in terms of it is more high level language than FunC.
Yeah, exactly. Okay. The question about VS Code extension is VS Code extension marketplace. There are 2 extensions, one from Convik and the other from Ton Community. So which one?
We recommend using the one from Convik. This is most featureful and up to date.
Okay. Next question: is there any solution to put image on IPFS for NFT? No, it's not actually a question about TACT, but yes, sure, you can do it. You can put hash from IPFS to your NFT contract on TACT. I don't know what to say else. Anton, what do you think?
Yeah, I mean, got nothing else to add. Sorry.
Yeah. Next question. I have a question about user safety. I have heard that some smart contracts are made in such a way that people buy tokens but cannot use them. Who can moderate contracts like that? Actually, if we use if we use standards, we don't how to say, if your token exist on exchanges, and I think its problem was maybe in 2017, but I didn't heard about something like that. Yeah, audit. Okay, I continue. Besides running TACT smart contract, is there any other solution to reduce gas consumption? Anton, what do you What do you think about it?
I would guess it's something like switching to fancy. So let me reiterate something. I don't really understand the question, but what we recommend is to build kind of your business logic, the main logic of your system using TACT. And then if there are some parts that need gas optimizations, then rewrite that part, small part in fancy. So that way you can actually reduce gas consumption. But TACT is like young development language, so you might actually expect this issue of gas consumption fixed maybe in the third quarter of this year. Yeah, there are some plans. I cannot disclose all of that, but something is cooking.
Yeah. Good. Next question: how to verify TACT contract? Need convert to fancy? And I know answer that no, you don't have to do it. Yeah, I know service verifier. How it names? Tone verifier, I guess. Okay, I think I just send a link to our main group. Yeah, and there is possibility to verify TACT contract, fancy contract. So yeah, it's like in Etherscan, if you know how to verify solidity contracts, it's very similar. Okay. One more question about gas, but so I skip it. Yeah, do I understand correctly that you are now showing how to make your project? Yes, it is. Are there any sorry. Are there any options to work in this language, and where? In Tonica system, I guess. Where else? Okay, why this code will not gonna work on a huge scale of users? I guess this question about hash, about map of backers, right?
Right, yeah. So basically why this is not going to work is that you have the info about who donated and how much in one single map. And there are some blockchain limits on how much data can one contract store. And it's basically tens of kilobytes. And so imagine if you have millions of users, that is immediately like more than 1 megabyte at least, right? So this is not accessible. So this scalability design for the Ton blockchain actually imposes some constraints. You cannot have contracts with huge amount of code and huge amount of data, as opposed to, let's say, Ethereum.
Okay, there are a few questions left, so let's do it. In case not the contract owner calls, if exception is raised, can I list several addresses that have a right to call? Yes, you can, because
sure.
Yes, blockchain is open network. You can see transactions, you can see everything, so you can do it.
I think that maybe the question is, if I understand correctly, about can we have like multiple owners, let's say. So yeah, there are several solutions. You can support multiple owners in your contract. You just change the logic, saying that this address can call, maybe you have like 2 or 3 owners and you would just do something like you would add owner, like owner2, and then here you would
map of contract. Yeah.
And here you would say that the deployer would have to also say something like this. This is going to be owner2, right? So something like this is possible, or you can use, like, you can solve it on a different level, right? You can use multi-signature wallets. So basically a wallet, so here you would be only saving one address, but that multi-signature wallet can be operated by several people actually.
Yeah, thank you, Anton, to check me. Okay, let's continue. Same question again. No, sorry. What are the differences between scalable contract, more million users, or not scalable 100 users? Actually,
yeah, there will be significant difference. So for instance, we will have to ditch the map from the contract and deploy contracts with this info basic. So we will have to essentially have the same information, but a totally different representation. So we will be looking at this next time.
Okay, nice. And wow, a few more. Okay, how can I check if the code is working correctly or not? We will do it next workshop, I guess.
Yeah, exactly. Yeah, there is the Blueprint framework, and it has the Jest support for basically Tom TypeScript wrappers. So yeah, we will be covering this next time.
Okay, tomorrow, right? We'll do it tomorrow.
Yeah.
Okay, next question is good as well. Is there a way to debug code besides unit tests?
Yeah, I mean, you can use the dump instruction, for instance. So for instance, you can go here and let's say you want to debug. Oops, sorry. There is this debugging smart contracts. And so for instance, here's this reference about dumping. The example here in the tag docs actually uses tag blank emulator, but we will be covering analogous thing with Blueprint and the libraries it actually supports. So yeah, you can dump stuff, or you can use just like tests.
Okay, there are two questions left. How fast the smart contract may be executed? Is it a good idea to use it in real game? Is it a good idea to use it in real time inside the game, or better to execute transactions in the background? So
I think it might not be a really good idea to use it like in a real-time system, because like blockchain has some latency. You know, if it is congested, if there's like lots of activity at this moment, then it won't be able to process it like in real-time fashion.
I think same. It takes around 4-5 seconds each transaction. So yeah, you can keep it in your mind to build your game. Okay, and last question. Yeah, how does TACT simplify the interaction of smart contracts with external systems?
I'm not sure what external systems mean in this context, but basically it simplifies stuff by letting you not deal with low-level things like serialization of messages, deserialization, or parsing of binary encoded messages. So that kind of stuff.
I think it's about external messages question, maybe.
It might be. There is support for externals. There's keyword external. Not sure that we will be covering this stuff here. And getters are as well some ways, right, to read the contract state, for instance, from some external world, let's say.
Yeah, okay. So, Anton, thank you so much. It's our biggest workshop, and it's very nice because lots important information from you and lots of good questions. So thank you guys too. I am enjoying this workshop.
Thank you, Vladimir. Thanks everybody for joining us. Thanks for having me. Thanks for all the great questions. Really was a pleasure for me.
Yeah, and good luck on hackathon. Have a good day, and tomorrow, yes, see you.
See you tomorrow. Thank you.